You ever get that feeling like AI is moving so fast you can barely keep up?
Oh yeah, it's like drinking from a fire hose.
Right. One minute it's self-driving cars, the next it's AI writing movie scripts.
Mind-boggling, the pace of advancement.
And it's not just the algorithms themselves, it's the whole process of developing and deploying them.
It really is.
Which brings us to today's deep dive. MOps. Now, I'm sure you're hearing this term everywhere.
Oh, absolutely, it's everywhere.
But what does it really mean, especially for someone who's already familiar with the basics of AI? We've got some sources that suggest it's not just hype, it's actually changing how AI is being used.
Exactly. MLOps is kind of like building a bridge, right? Between that theoretical world of machine learning models and the real-world applications we're all starting to see. And our sources today, well, they focus on a simplified workflow using, well, some big names, PyTorch, Arm, and GitHub collaboration.
Okay, so we're talking some heavy hitters here.
Definitely. And it's a great example of how MLOps is becoming more accessible, even for smaller teams.
That's really interesting. So let's break this down a little. We know data scientists build these complex models, but then what?
That's where the traditional software development lifecycle, it gets a bit of a makeover for ML. Instead of just a straight line from coding to launch, it becomes a cycle.
Oh, I see. So it's more dynamic.
Much more. You start with data, use it to train your model, deploy it, and then here's the crucial part, it gathers new data and feedback.
And that feedback loop, that's important, right?
It's key. You use that feedback to actually improve the model, retrain it, and then redeploy it.
So it's not just a one and done situation.
Not at all. The model's constantly learning and evolving.
That makes sense.
Yeah.
So can you give me an example, like something that illustrates this, something I can wrap my head around?
Sure, think of self-driving cars, right?
Okay, yeah.
They use machine learning to navigate, to make decisions. But every time a car drives, it's gathering data, learning from it, and getting better.
So that continuous improvement, that's MLOps in action.
That's
Okay, so where does GitHub fit into all of this? I mean, they're known for code collaboration, not necessarily AI development, right?
right. But GitHub, well, it's become the central hub for developers of all kinds, including data scientists. And what they've recognized is that MLOps can involve a lot of repetitive tasks.
I can see that.
Things like data pre-processing, model training, deployment, monitoring, and, what's the best way to handle repetitive tasks?
Automate them.
Right.
You got it.
Okay, this is starting to click now. So streamlining and automating the whole process, that's where GitHub Actions comes in.
Bingo. GitHub Actions, it's their automation tool, and it's becoming, well, a game changer for MLOps.
I can see how that would be really powerful.
Imagine you have a model deployed, right? And every time new data comes in, it automatically triggers retraining and redeployment, making the model more accurate, more adaptable over time.
Wow.
It's like having a self-updating AI, always learning, getting better.
Pretty powerful stuff.
It is. But we've also got Arm in the mix here. Now, I know they're big in the hardware world, especially for energy-efficient chips.
Right, and that's where things get really interesting. Arm, they've actually developed a new learning path that specifically focuses on this MLOps workflow, and they break down each phase with real code examples. They use a practical project, too.
Oh, tell me more about that.
They're training a PyTorch model to, well, recognize traffic signs, to demonstrate these concepts. But they don't just stop at the basics. They really go deep, exploring some pretty advanced strategies.
So it's not just theory, it's real-world, hands-on learning.
Absolutely. Like, for example, they explore containerization.
Containerization.
Yeah, which basically ensures your model can run consistently in different environments.
Oh, okay, I see.
Which is crucial for scalability, right? You can go from testing on your laptop to deploying on a cloud server seamlessly.
So it's like packaging your model in a way that makes it portable and reliable no matter where it's running.
Exactly. That's a great analogy. They also dive into data loading optimization.
And why is that so important?
Well, machine learning models, they're data hungry.
Makes sense.
You need to feed them data efficiently. Otherwise, you're wasting time waiting for the model to train.
Right. Time is money, especially in the fast-paced world of AI. But optimizing data loading, how technical does that get? Would this learning path be helpful for someone who's not, a hardcore developer?
That's what's great about it. They strike a good balance between theory and practice. They explain the concepts, in a way that's understandable, but they also provide enough code, enough guidance to actually get you up and running.
Okay, that makes sense.
They even delve into model optimization.
Model optimization, now that's a term I've heard, but to be honest, it sounds a bit intimidating.
Yeah, I can see that.
Like, do I need a PhD in mathematics to understand it?
Not at all. It's really about making your model more efficient, without sacrificing accuracy, of course.
So it's like fine-tuning an engine to get the best performance.
Yeah, that's a good way to think about it. And they compare, using those general purpose libraries, things like OpenBS and 1DNN,
Okay,
which work well across different hardware,
sure.
to Arm Compute Library, which is specifically designed for Arm's architecture.
So it's about choosing the right tool for the job.
Yeah.
But why would you choose ARM over these other libraries?
That's a great question, and it really gets to the heart of why Arm is becoming such a big player in the AI space. Their processors are incredibly energy efficient,
Right.
which is crucial for, well, edge devices, mobile applications. Imagine, deploying a complex AI model on a drone
Okay, yeah.
or a smartphone. You need it to be powerful, but you also need it to sip power.
Makes sense. So ARM Compute Library, it helps you kind of squeeze out that maximum performance while using minimal energy.
Exactly.
That's a big win, especially if you're thinking about, AI on the go.
For sure.
But let's zoom out for a second here.
Sure.
We've been talking about the nuts and bolts of this MLOps workflow. But what's the bigger picture?
Okay.
Why should businesses care about all of this?
It's about bringing, well, the rigor of software engineering to AI development. Traditionally, there's been a disconnect between data scientists who are building models in the lab and engineers deploying them in the real world.
Yeah.
MLOps bridges that gap,
That-
creates a unified workflow.
So it's not just about the technology.
Yeah.
It's about the process, the people involved.
Precisely. It's about fostering that collaboration,
Right.
creating a culture of continuous improvement.
Yeah.
And the benefits are tangible. Faster deployment, reduced costs, improved model accuracy, ultimately a competitive edge.
So this isn't just some trendy buzzword.
Definitely not.
It's something that can have a real impact on the bottom line.
Absolutely. And as AI becomes, well, more integrated into every aspect of business, MLOps, it's becoming essential.
So let's say a business leader's listening to this, nodding their head, thinking, all right, I'm sold.
Yep.
But where do I even begin? How do I start implementing MLOps in my organization?
It can seem daunting, but the good news is there are resources available.
Okay, good.
This ARM learning path we've been talking about, it's a great starting point.
Yeah,
It provides a practical roadmap for building an MLOps pipeline.
that's helpful.
There are also, consulting firms, tech providers,
Right.
specializing in MLOps that can help guide organizations through the process.
So there's a whole ecosystem emerging around MLOps. But even with all those resources, where do you even start internally?
Well, one of the most important things is, fostering that collaboration between data science and engineering teams.
Yeah.
Break down those silos.
Oh, yeah.
Get everyone working together, towards a common goal.
Right. Get everyone speaking the same language.
Exactly. And don't be afraid to, experiment and learn. MLOps, it's an ongoing journey.
It's not like you flip a switch and suddenly you're doing MLOps.
Right.
It's a process of evolution, continuous improvement.
Couldn't have said it better myself. It's about constantly iterating, adapting to, new challenges and new opportunities.
We've covered a lot of ground here, from those technical details to the broader implications of MLOps.
We have.
But before we wrap up this part of the dive, is there anything else we could touch on?
Well, we've talked about the how of MLOps, but what about the why? This learning path uses a traffic sign recognition project as an example,
Right.
which seems, like a simple choice.
Yeah, at first glance, it doesn't seem, particularly groundbreaking. Why traffic signs?
It's actually quite clever. We encounter traffic signs every day, so it's relatable, but it also highlights those complexities of training a model to handle, real-world conditions.
Okay. Yeah.
Different lighting, weather, angles.
So it's not just about getting the model to work in a pristine lab setting.
Exactly.
It's about building something robust enough to handle, messiness of the real world.
That's it. It's a problem with real-world applications in areas like, self-driving cars and traffic management systems. Plus, using a familiar object like a traffic sign, it makes the complex world of PyTorch and model compilation a bit easier to grasp.
Okay, I'm starting to see the method to their madness. So they're using this traffic sign project to teach us how to build a complete MLOps pipeline with PyTorch.
Right, and they go beyond just training the model. They delve into different approaches to model compilation, comparing those general-purpose libraries, remember those, to the Arm Compute Library. This gets to the heart of why Arm is making waves in AI.
Because of their focus on energy efficiency.
Exactly. By showing how to optimize a model for Arm's architecture, they're essentially demonstrating how to build AI that can run on anything from a powerful server to a tiny, low-power device.
So it's not just about building a model. It's about building a model that can be deployed anywhere and everywhere. That's pretty cool.
It is, and it highlights the importance of, well, thinking about hardware and software together when you're designing your MLOps workflow.
Wow. It's amazing to think we've already covered so much. We've gone from that high-level concept of MLOps to, really specific stuff like data loading and model optimization. But I still feel like we're just scratching the surface.
I think you're right. The field is constantly evolving. New tools, new techniques emerging all the time.
It's a dynamic space. That's what makes it so exciting.
Yeah.
So where do you see things heading? What's on the horizon for MLOps?
Well, one trend I'm really excited about is the increasing focus on automation. We talked about GitHub Actions, but it goes way beyond that. We're seeing these incredible advancements in, well, AutoML, for example.
AutoML, I've heard that term, but I have to admit I'm not entirely sure what it means.
So imagine, you're a data scientist, and instead of spending weeks, even months, manually tweaking models, tuning those hyperparameters, you have an AI assistant doing all the heavy lifting for you.
So it's like AI building AI.
Basically, that's essentially what AutoML is, automating that process of model selection and optimization.
That's amazing.
And what's remarkable is that AutoML is already producing models that are as good as, if not better than, those built by human experts, at least in some cases.
Wow. So it's not just about saving time. It's about potentially improving the quality of the models themselves.
Exactly.
That's a real game changer. But what about getting those models out into the world? We talked about deployment. Is that something that can be automated as well?
Oh, absolutely. Automated model deployment, it's another area where we're seeing a ton of innovation. Think about it. You've built this amazing model, but it's useless if it's just sitting on your computer. You need to get it into production, where it can actually do something.
So automated deployment, it kind of takes the headache out of getting those models out there working, doing their thing.
Right. It helps you package your model, deploy it to various environments, whether it's the cloud, an on-premise server, or even a tiny edge device, and even scale it up or down as needed.
Wow. So we're talking about a fully automated pipeline from data pre-processing to model training, optimization, and deployment. That's powerful stuff.
It is, and that's what's driving the democratization of AI. It's making these tools and techniques accessible to, a much wider range of organizations and individuals, not just those with huge data science teams and tons of resources.
So MLOps, it's not just a technical discipline, it's a movement. It's changing how we think about and interact with AI.
I completely agree. It's breaking down barriers and empowering more people to, harness the power of AI.
Okay, so let's wrap this up. If you had to distill everything we've discussed into one key takeaway, what would it be? What's the most important thing for our listeners to walk away with?
I think it's this. MLOps is more than just a set of tools and techniques. It's a mindset shift.
Okay, I like that.
It's about bringing together the best of software engineering and machine learning to build AI systems that are, robust, reliable, scalable. It's about bridging the gap between the potential of AI and the reality of deploying it in the real world in a way that benefits everyone.
That's a great way to put it. And this ARM learning path we've been discussing, it seems like an excellent place for anyone to start their own MLOps journey. We'll be sure to include that link in the show notes.
It's a fantastic resource, really. Packed with practical examples, code. I highly recommend checking it out.
And as always, we encourage you to dive deeper into the world of MLOps. Explore the resources we've mentioned, experiment with the tools, and see where this incredible journey takes you. Who knows, maybe you'll be building your own MLOps pipeline soon.
The possibilities are truly endless.
Until next time, keep on learning and diving deep.